Lastly, when we think about soil transformations, we also have to think about losses. Now, to put this in context, what we just covered was that we thought about additions to soils and those factors that add new materials to soils, and then also transformations and how primary minerals, for example, in organic matter, are transformed and changed into new substances that alter the soil properties. Thirdly, we had transfers, and there were different factors that cause materials to move down in a soil profile, but also up in a soil profile. And here we're going to talk about, really briefly, some of the losses that occur. The authors state that materials are lost from soil profiles primarily as solutions and gases. And we covered this before as far as the ions that are lost from soils. There's a specific order that they're lost. So for example, you're a lot more likely to lose chloride out the bottom than you are aluminum initially. And it's generally only after the chloride is lost that you start to move down this sequence to other cations and ions that are lost. Now, the amount of loss from a system is going to be dependent on the amount of water. The more water that you have moving through a system, the more likely it is that materials are going to leave with that water. In addition, solute concentration is important, and the amount of anions or cations that you have in solution are going to determine how much leave with a given amount of water. So if there's plants around that are taking up anions and cations and your concentration of solutes is relatively low, then you're a lot less likely to lose solutes. But if for some reason there aren't a lot of plants taking up those solutes, concentrations in the soil solution will be high and you're going to lose a lot more. And also there's the idea that there's monovalent before divalent ions are lost. And this was just the sequence that we looked at, that you're a lot more likely to lose chloride before something like calcium 2+, or potassium before calcium. Now, another thing to think about, and I think we'll talk about this later too, is charge balance. And essentially, this is important because if you think about water moving through the system, if you only were to lose chloride, those soils would become, as a consequence, positively charged. So you'd be losing a lot of negative charge and the remaining soils would be positively charged. And it would get harder and harder to lose negatively charged ions. These anions would be a lot harder to lose. So in general, for every ion that you lose, you're going to lose a cation too. And there's going to be charge balance. So potassium is more likely to be lost with chloride, for example. And that if you have 2 chlorides that are lost, that would balance the charge for 1 calcium. So there's charge balance too, and there's a specific order that we lose ions, and there's a balance to the types of ions that we lose. Now, one place that this becomes important is thinking about acid rain. Because what acid rain does is it brings in 2 things. It brings in protons, that's the acid part, but it's also going to bring in the other half of the equation too. And it's going to bring in some kind of anion too. So if it's sulfuric acid that's coming down, that's going to be your ion to go with the protons, or it might be something like nitric acid, and you'll have a nitrate too that comes along with the proton. So what happens is that when you're adding a lot of protons and a lot of these anions, that's going to displace cations, for example. And so the more acid that you put in to a soil, now you might lose acid out the bottom too, but if there's potassium, for example, or calcium within those soils that's available for exchange, the protons and the calcium are going to exchange, calcium goes into solution, and then it goes out the bottom too. So one of the consequences of acid rain is not just having a lower pH, a greater acidity to soil solution, but all of these additional cations that you lose from the system. One of the ways that scientists are starting to take a look at the consequences of acid rain, even after acid rain has stopped, has been to think about the consequences of all the cations that get lost because of the acidity that's been added to the system. So for example, at Hubbard Brook, which is in New Hampshire, it's an LTER site, a long-term ecological research site. They're currently conducting an experiment where they're trying to replace all of the calcium that's been lost from a forest by replacing it with fertilizer calcium. So they take these large bags of calcium-containing mineral, put them in a hopper, get a helicopter, and then take that helicopter up to a watershed and dump it on the watershed. And it's a large-scale fertilization with little calcium-containing pellets that then hit the system and have replaced all the calcium that's been lost over the past few decades. These are the types of experiments that are currently being done by ecologists that are helping us to understand what some of the patterns are of losses and the consequences of losing both anions and cations from systems.